So in the next section, we are going to see the relationship between the electric field intensity and the magnetic field intensity. So here also we can start with the Maxwell's equation. We know that del cross H will be is equal to dou B by dou T. That is determinant of Ax, Ay, Az, dou by dou X, dou by dou Y, dou by dou Z, Hx, Hy, Sz will be is equal to epsilon 0 into dou E by dou T. That is Ax into dou Hz by dou Y minus dou Hy by dou Z minus Ay into dou Hz by dou X minus dou Hx by dou Y plus Az into dou Hy by dou X minus dou Hy by dou Hx by dou Y. It's equal to epsilon 0 into, you can substitute dou E by dou T as dou Ex by dou T into Ax plus dou Ey by dou T into Ay plus dou Ez by dou T into Az. Consider that the fact that E and H are independent of X and Y and H of Z is equal to E of Z is equal to 0. So if you substitute H of Z, E of Z is equal to 0 in this equation, you will get minus A of X into dou Hy by dou Z plus Ay into dou Hx by dou Z is equal to epsilon 0 into dou Ex by dou T into Ax plus dou Ey by dou T into Ay. So equating the coefficient of unit vectors, that is equating the coefficient of Ax and Ay. By equating the coefficient of Ax, you will get dou H minus dou Hy by dou Z is equal to epsilon 0 into dou Ex by dou T, and equating the coefficient of Ay, you will get dou Hx by dou Z will be equal to epsilon 0 into dou Ey by dou T. So a plane wave is positive direction can be denoted as a function of Z minus Vt, that is a positive Z direction. That is a plane, that is a wave that propagates in a positive Z direction can be written as a function of Z minus Vt. So we take E of X is equal to a function of Z minus Vt. So to facilitate the integration, we change the time derivative into the derivative with respect to Z. Differentiating with respect to Z, we get dou Ex by dou T is equal to minus V into dou Ex by dou Z. So we have the equation minus dou Hy by dou Z is equal to epsilon 0 into dou Ex by dou T. So instead of dou Ex by dou T, you can substitute this value, that is minus V into dou Ex by dou Z. Therefore, the equation becomes minus dou Hy by dou Z is equal to epsilon 0 into, instead of this value, it is minus V into dou Ex by dou Z. Therefore, dou Hy by dou Z is equal to epsilon 0 V into dou Ex by dou Z. On integrating, we get Hy is equal to epsilon 0 V into Ex. Integrating this equation, you get Hy is equal to epsilon 0 V into Ex. Similarly, Hx will be equal to minus epsilon 0 V into Ey. And we know that the velocity V will be equal to 1 by root mu epsilon. In free space, mu is equal to mu 0 and epsilon is equal to epsilon 0, you will get V is equal to 1 by root mu 0 epsilon 0. And Ex will be equal to Hy by mu epsilon 0 into V from this equation. And we substitute the value of V in this equation, you will get Ex will be equal to Hy by epsilon 0 by root of mu 0 epsilon 0. And Ex will be equal to Hy into root mu 0 by epsilon 0. Similarly, Ey will be equal to minus Hx into root mu 0 by epsilon 0. We have E square will be equal to X square plus Ey square plus Ex square. We know that Ez will be equal to 0. Therefore, E square is equal to X square plus Ey square. Substituting these two values in this here, you will get E square will be equal to root of mu 0 by epsilon 0 Hx the whole square plus root of mu 0 by epsilon 0 Hy the whole square will be equal to mu 0 by epsilon 0 into Hx square plus Hy square. And E square will be equal to mu 0 by epsilon 0 into X square. Therefore, E square by H square is equal to mu 0 by epsilon 0 and E by H is equal to root mu 0 by epsilon 0 will be equal to K, where root mu by H is known as the intrinsic impedance, or E by H is equal to root mu 0 by epsilon 0, because we are now considering the free space. Here mu is equal to mu 0 and epsilon is equal to epsilon 0. By substituting the value of mu 0 and epsilon 0, you will get E by H is equal to 377 ohm. That is the intrinsic impedance. That is the ratio of electric field intensity to magnetic field intensity is the intrinsic impedance. And the value is 377 ohm. It's a very important portion, that is the relationship between the electric field intensity and magnetic field intensity. The ratio of electric field intensity to magnetic field intensity is the intrinsic impedance, and the value is 377. Next, you can go through the properties of a uniform plane where you can read yourself that all these things you know very well. And we can see the two problems, numericals, that is find the velocity of a plane wave in a lossless medium. Here, which is very important to see, it is a lossless medium having a relative permittivity of 5 and relative permittivity of 20. You know that the equation velocity v is equal to 1 by root mu epsilon will be is equal to 1 by root mu 0 epsilon 0 mu r into epsilon r. You know the value of mu 0 and epsilon 0, and here the permeability is 1 and permittivity is 5, so you will get the answer 1.8 into 10 raised to 8. Similar way we have the next question, you can go through that question also. And thank you. This is all about the module 5, a very important module. Thank you.